Okay, let's continue on to part C, which is the integral of 3x squared times the square root of x cubed minus 2. Again, this is a classic u substitution problem. So we're going to let u equal whatever the inside is. In this case, it's x cubed minus 2. Step 2, we're going to take the derivative of both sides. We end up with du dx equals the derivative of x cubed minus 2, which is 3x squared. Third step is we solve for dx. If I solve for dx, I have dx equals du over 3x squared. We go in and we substitute this into our integral. Again, what are we substituting in? Is the dx value and also the u value. So when I look at this integral and I rewrite it, it would be the integral of, the integral of, the 3x squared is still there, and then instead of the square root of x cubed minus 2, I'm going to write it as u to the 1/2. Let me clean that up, u to the 1/2. And instead of dx, I'm going to have du over 3x squared. Notice those 3x squared simplify, so this integral turns into the simple integral of u to the 1/2 du. Now that it's all in terms of u, we're able to integrate it, so the integral of u to the 1/2 would be u to the 3/2. Then it's divided by 3/2, which is the same thing as multiplying it by the reciprocal of 2/3. Of course, we need the plus c. No simplification there, so we can move on to step 6, which just requires us to back substitute for u. So in this case, this would be 2/3. U was x cubed minus 2 to the 3/2. Then we have our plus c. Again, how would we know this is right? Go ahead and take the derivative of the answer, and when you take the derivative of the answer, you will get the exact same thing as the original problem. So 2/3 times x cubed minus 2 raised to the 3/2 plus c. Again, no need to change this back into radical form. I'm perfectly fine with you leaving it in exponential form. Let's look at the next one here. It's the integral of negative 4x over 1 minus 2x squared quantity squared. Okay, so this is again another great example of a u substitution problem. So let's let u equal 1 minus 2x squared, the inside of the function. Step 2 is differentiate both sides, so that's du dx equals, well, the derivative of 1 minus 2x squared would be a negative 4x. Step 3 is solve for that dx, so if we solve for dx, we'd have dx equals du over negative 4x. And that's going to allow us to substitute into the problem, and let's see what we end up with. So again, what are we substituting in? We're substituting in for dx, and we're also substituting in for u. So when we rewrite this integral, it would turn into the integral of negative 4x all over, instead of 1 minus 2x squared, quantity squared, that's going to be a u squared. And then instead of dx, we have a du over negative 4x. Well, that's nice because look what happens. We simplify our negative 4x's, and we end up with, I'm going to rewrite this as the integral of, I'm going to go ahead and write it as u to the negative 2 du, so we can use the power rule on this. Now that it's all in terms of u, we can actually integrate. The integral of u to the negative 2 would be u to the negative 1 over negative 1, which would just be negative u to the negative 1 plus c. Or if we want to simplify that, that would be negative 1 over u plus c. That allows us to go to our last step, and again, the last step, the only thing that we're doing is back substituting in for u, and u was 1 minus 2x squared. So the final answer we should have here would be negative 1 over 1 minus 2x squared plus c. How would we know that answer is right? Again, you would check by finding the derivative. So again, the answer was negative 1 over 1 minus 2x squared plus c. Okay. Let's move on to the last problem on this page. How about the integral of cosine squared x sine of x? Again, you're looking for which one has the higher power here. So in this case, that's cosine of x. So we're going to let u equal cosine of x. When we do that, we move on to step 2, differentiating both sides. We'd have du dx would then equal, well, the derivative of cosine of x, remember that negative sign, it's negative sine of x. So if we solve for dx in this case, we would have dx would equal du over negative sine of x. So let's go ahead and plug that into the original integral. Again, what are we plugging in? We're plugging in dx. Instead of dx, we're going to plug in du over negative sine of x. And instead of cosine of x, we're going to plug in u. So this is really the integral of instead of cosine squared of x, that would be u squared. Then we still have the sine of x, and then dx would be du over negative sine of x. When we do that, our sine of x is simplify. We can pull the negative out in front, so it would be negative the integral of u squared du, which is simple enough for us to integrate because it's all in terms of u. So this would equal negative the integral of u squared would be u cubed over 3, so that would be 1/3 u cubed plus c. So in this case, that's all we can do for simplification. So let's go ahead and do our last step. Again, that last step is just back substituting for u. So we would have negative 1/3 times u, which was cosine of x, cubed plus c. That should be our answer there. Of course, we could write it a little bit differently if we wanted to. This would be negative 1/3. You could write it as cosine cubed of x plus c. Either of those formats, I truly don't care. That's your final answer. How do we know it's our final answer? Again, take the derivative of that and you should get the original problem.